power function of degree n is a monomial that can be written in the form f at x is equal to a sub n, which is a coefficient, on x raised to the nth power. In this example, we're asked to graph a transformation of a power function, and what we want to notice first of all is that the initial power function that is to be transformed is x raised to the fifth power. The -2 and the -1 are transformations of this graph. As a reminder, x to the fifth power has 3 points of interest, 0, 0, 1, 1, and -1, -1. It's a vertical snake-like graph that's kind of boxy and kind of steep down here at the origin. But it is still a polynomial, so the graph would be smooth and continuous with no sharp corners. As a reminder, the order that we want to perform these transformations in is that we want to apply all multipliers first, which are the stretches and compresses and reflections. And then after we do that, we can do the shifting up, down, left, and right. And the shifts happen when we add or subtract values. So this -2 multiplier needs to be applied first. Since this -2 is on the outside, it corresponds to a vertical transformation. The vertical transformations are logical, and they're applied to the y-coordinates of the ordered pairs. So what we're going to do to the y-coordinates of these points of interest is what we see. We do what we see, which is to multiply the y values by -2. When we do that, we get the graph of y is equal to -2, x to the fifth power. And each of these ordered pairs is going to be transformed individually by, again, multiplying the y-coordinates by -2. 0, 0, when we multiply y by -2, that ordered pair doesn't go anywhere. But in the 1, 1 ordered pair, we multiply 1 by -2 to get -2, so the ordered pair 1, -2 is where that point lands. In the -1, -1 ordered pair, we multiply the y-coordinate by -2, and this ordered pair jumps to -1, +2. And what we see is that we have a vertical snake graph that has been vertically flipped and stretched out by a factor of 2, all with this one transformation. The next thing that we need to do is this inside transformation, and because this -1 or the -1 is happening on the inside, that means that the transformation is horizontal, backwards from logic, and affecting the x-coordinates of the ordered pairs. So from here, we're going to add 1, not subtract 1, that would be logical, right? This is backwards from logic. We're adding 1 to each of the x values. So essentially, we're shifting this to the right 1 unit. So add 1 to the x value of the 0, 0 ordered pair, and we end up with an ordered pair at 1, 0. Since this is our last transformation, we're going to put this on the final answer Cartesian plane. The ordered pair 1, -2 will add 1 to the x-coordinate so that that ordered pair then lands at 2, -2. The ordered pair -1, +2, we're going to add 1 to the x-coordinate here so that this ordered pair then lands at 0, +2. And then we connect the dots with a very steep and somewhat boxy vertical snake. And this is our final answer.